Picture this scenario. You have an area that is configured as a stub area. And that stub area has a router that's connected to another routing domain. It could be EIGRP. Or let's say it has an interface that you want to have redistributed, the network on that interface redistributed into the OSPF process. So that, I'm having trouble saying that right there. Okay, what do we do? Okay. Picture this scenario. You have an OSPF domain with an area. Let's call it Area 51. And Area 51 has a router in it that's connected up to another routing domain. Let's say it's EIGRP. Or let's even say that there is an interface connected to that router, so a directly connected network, that you want to be advertised into the OSPF domain. However, you do not want OSPF enabled on that interface, so instead you perform redistribution on that connected network. So whether you're performing redistribution on that connected network or whether you're performing redistribution on that router for the EIGRP networks in a completely different routing domain. Remember what I said, that router is in a stub network. Can you do that? Well, you can configure redistribution if you want to, but will it work? Will it work? Let's check that out. Right now, I have R7 configured to redistribute the 172.16.32.192 network into the OSPF domain. So that interface right now, Fast Ethernet 2/1, is not participating in the OSPF process. It is simply being redistributed. So I accomplished that on R5, or R7, pardon me, by configuring this command right here, show run pipe to section router OSPF. The command I used was redistribute connected subnets. So that directly connected network is being redistributed. Notice, though, that area 567 is a stub area. If we analyze R5, show run, or show, let's use this command, show IP OSPF, we'll see that area 567 is a stub area. We go to R6, show IP OSPF. We can see from this output that area 567 is a stub area. And what do stub areas prevent? Stub areas prevent type 5 LSAs. So when I perform redistribution on R7 right now, is that type 5 LSA even allowed into area 567? The answer to that is no. It's not allowed in the area 567. So if we go to R7 now, and we look at the database, show IP OSPF database, what do we see in the type 5 LSAs? You see any? Nope. There are no type 5 LSAs listed in the database. So if we analyze R5 or R6, show IP OSPF database, we'll see here that for the type 5 LSAs, we have everything except for the 172.16.32.192 network. It's not listed there. Because type 5 LSAs are not allowed in area 567. Same thing would be true on R6. So how can we solve this problem? Well, the problem right now is that it's a stub area, and stub areas suppress type 5 LSAs. What can we do? Well, we can completely get rid of the stub feature if we want to. So remove the fact that it's a stub area. However, we are implementing the stub area feature because our goal is to reduce the number of LSAs that are going into area 567. We are preventing those type 5 LSAs that are coming all the way from the EIGRP autonomous system on the other side from being sent into that area 567. So we don't want to just shut off the stub area feature. Instead, what we can do is we can change that stub area to a not so stubby area, because the not so stubby area still prevents type 5 LSAs. But what it will do is it will allow type 7 LSAs. So the autonomous system boundary router now, which is going to be R7, is going to instead create a type 7 LSA that it sends into that not so stubby area, so area 567. And then that way their R5 and R6 can learn about it. And since R5 and R6 are area border routers, they will convert that to a type 5 LSA and send it into area 0 within our topology. But the command to do that is to remove that stub area feature on all of the routers in that area. So in our case, area 567. And then on the area border routers, implement the area ID 567 in our case, not so stubby area command, so NSSA, on all of them. So area 5, 6, and 7, all three of those routers. However, on the area border routers, we want to issue the default information originate command, because by default, when you use NSSA, the area border routers will not, by default, inject a default route into that area. And we still need that default route injected to the area so the users in area 567 can still reach the internet within our topology. So if we look at our topology again, we'll see that it's really important that we implement the not so stubby area feature here. So that way there we can still get that directly connected network off of R7 redistributed into area 567. It'll be redistributed as a type 7 LSA, and then R5 and R6 will convert it over to type 5 as it advertises that into area 0. But don't forget about the default information keyword, so that way there R7 can still reach the internet and can still reach that EIGRP autonomous system of 100. So let's get started on the config here. Configure terminal. We'll type in interface, or not interface, router OSPF1. And we'll say no area 567 stub. And then we'll say area 567 and SSA default information originate. We'll go over to R6. We'll type in configure terminal, router OSPF1, no area 567 stub. And then we'll say area 567 and SSA default information originate. And then over on R7, we'll configure it as just NSSA. We won't need to put in the default information originate keyword. So router OSPF1, no area 567 stub, and then area 567 and SSA. So now if we look at the output of show IP OSPF, we'll see down at the bottom it says this is an NSSA area. So NSSA areas will allow us to have those type 5 LSAs, which are referencing external routes. So let's issue the command now, show IP OSPF database on R7, and we'll see that now we have a type 7 external LSA created. And it is our 172.16.32.192 network that is being redistributed via redistribute connected subnets command that we typed in earlier. If we look at R5 and R6, we'll see here, show IP OSPF database, that the type 7 is listed down at the bottom as well. And we can see the entry right there. But notice that we also have an entry for that exact same network as a type 5 LSA, because in area 0, that network's considered a type 5, whereas in area 567, because it's an NSSA area, it's considered as a type 7. So now our users should be able to reach that particular network because they will have learned about it. The routers would have learned about it. So if we go to R4, show IP route, we can see here that the 172 network is being learned right here. 172.16.32.192/29 is being learned right there, because it's being allowed via the type 7 LSA into area 567. So if you have a missing route in your environment and you have a stub area, or you have a missing route due to redistribution and there is a stub area, you need a not so stubby area to solve the problem or completely remove the stub area feature.